In this video, we're going to be talking about permutations and combinations and about order and whether it matters or not. First, we've talked about the counting principle. That applies when we're selecting one item from each group. It also applies when an event is happening multiple times, such as flipping a coin 3 times or spinning a spinner 4 times. We can determine the number of outcomes by multiplying the possibilities in each group or event. So for example, I'm making a sandwich, I have 4 choices of meat, 2 choices of bread, 3 choices of cheese. How many different sandwiches can I make? I just multiply 4 times 2 times 3. I'm choosing one from each category. I'm spinning a spinner 3 times. The spinner has 1 red space and 1 yellow space. What's the probability that spin a red space all 3 times? Define the number of outcomes. There's 2 outcomes every time. There are 3 events. 2 times 2 times 2 is 8. There's going to be 1 outcome that has a red space all 3 times. So that probability is going to be 1/8. So the counting principle is when we're taking one item from each group, or in the case of the spinner, we're getting one outcome every time we spin the spinner. Then you just multiply the different possibilities together, and that will give you the total number of outcomes for that situation. But what if we're selecting multiple items from one group? How can we count the number of ways items can be selected or arranged from that one group? So let's say we're making a 3-digit code out of the letters A, B, and C. For a code, the order matters. How many codes can you come up with? Let's just see if we can come up with all of them. So we have A, B, C, of course. And then we could do A, C, B, of course. And then that's starting with A, that's all the possibilities there. And we could do BCA and BAC, that's all the possibilities with B starting first. And then with C starting first, we could do CBA and CAB. So there's 1, 2, 3, 4, 5, 6 different codes that I can come up with. That's it. But if we were making a 3-digit code out of all 26 letters, it would take us a long time to figure out all the possibilities. But there's a faster way to do it, and we'll talk about that in just a minute. Let's look at another example. Let's say we're picking a committee of 2 people out of a 4-person group. It doesn't really matter who gets picked first. I'm just going to pick 2 people. They're not going into any officer positions. We just need 2 people out of a 4-person group. And we're going to name the people A, B, C, and D just for simplification purposes. So here's what we could do. It could be A and B, A and C, A and D. With this, A and B is the same selection as B and A, so I don't need to count that one twice like I did in the last one. A and C is the same selection as C and A, so I don't need to count that different order. A selecting person A and C for the committee, it's the same committee if it's C and then A. Then we could do B and C and B and D. We don't need to do B and A because we've already done that one. And then we could do C and D, and again, we don't need to do C and A or C and B because those are already represented in the other groups. So we have a total of 1, 2, 3, 4, 5, 6 different ways that we could pick a committee out of 2 people out of a 4-person group. So I gave you an example where the order does matter, like making a code, and this is an example where the order doesn't matter. And again, if we had more people and we were selecting a group of more people out of that larger group, it would take us a long time to figure out the possibilities. So that's where we're going to figure out permutations and combinations. It's going to help us with that. Now, before we talk about how to answer those questions in permutations and combinations, we need to take a brief commercial break here to talk about a new operation called factorials. The product of all natural numbers from n to 1 is n factorial, which of course we read as n factorial, n exclamation point. It doesn't mean it's a really excited n. It just means that's an actual mathematical problem. So for example, when you see 9 exclamation point, it's not just a really excited 9. You would do in your calculator 9 times 8. I'm going to use the dot here for simplification purposes. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what 9 factorial is. You multiply 9 times everything all the way down to 1. Now, 16 factorial divided by 13 factorial. I'm going to pause the video here. There we go. Now, while it was paused, I wrote out all 16 factorial and 13 factorial. Now, but you can do that in your calculator pretty easily, and I'm going to show you the factorial button here in a second. But I want you to notice that these would all cancel out. These would all give me 1. 9 divided by 9, 8 divided by 8, those are all going to give me 1. So this is really like a bunch of 1s here that is multiplied times 16, 15, and 14. So you can do these problems a little bit more simply, still using a calculator, but without the factorial button, if you recognize that all of the 13 is going to cancel with all of the 13 up here and just leave you with 16 times 15 times 14. Now, 0 factorial is 1, and that's just by definition. We have just decided that 0 factorial is 1. All right, let me show you this on a calculator. There's a couple of places where you can find that factorial button. If you go to Math, you have a couple of menus here, Math, Numbers, this is complex numbers, and PRB stands for probability. So guess where we're going to go? That's right, we're going to go over to the probability menu, and you can see it's number 4. Now, I made a mistake here because I should have typed the number first, so it's going to take my previous answer times factorial, but I'm just going to use my cursor and go over here and change that to a 9 factorial, and you can see it does the 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, for me. Isn't that fantastic? I can go to alpha y equals and choose number 1 there, and I can do my 16 math over to PRB, choose number 4 over 13. And you should do that along with me. The more times you do it, the more you'll remember where it is. And we get 3,600. And of course, if I do 0 and choose number 4, it gives me 1. If you're lucky enough to have the CE model, you can go to alpha window, and it's also number 9 there. And again, I forgot to type the number first. So let me do that. Number 9, alpha window, choose number 9. All right, now, like we said, if we're counting arrangements from one single group and we're taking 2 or 3, or maybe we're taking all of them from that single group and the order matters, that's called a permutation. This would be like my code that I was picking out with A, B, and C. That's a permutation, an arrangement or a lineup of objects in which the order matters. And this is the formula for n things taken r at a time. That's how you read this. N things taken r at a time. It's n factorial over n minus r. You would do that subtraction first, factorial. N is the total number of objects. How many do you have in your group? R is how many is used in that arrangement. How many are you selecting? Examples would be arranging letters in a word, finishing first, second, and third would be a permutation. Batting order would be a permutation. Selection of officers is going to be a permutation. When you're trying to figure out how many I can select how many different ways I can select a group from a larger group and the order matters, that's permutation. Here's an example. 7 students are competing in a geography bee. How many ways can they finish first, second, and third place? So this is 7 things. So my n is 7. Taken r at a time, which is 3. We're going to take 3 at a time. And the order matters because it matters who's first, second, and third. So we do 7 factorial over 7 minus 3 factorial, and we follow order of operations and do what's in the parentheses first. Now, you can just do this in your calculator. You can also recognize, like I said, that 4, 3, 2, 1 is going to cancel with the 4, 3, 2, 1 here. So let me show you that one more time. And I'm going to be left with 7 times 6 times 5, which is 210. I could also just type this straight into my calculator, just like I showed you a second ago. Math, PRB, choose the exclamation point or alpha window. There's actually another way to do it using your calculator as well, and I'll show you that now. Lila, who has a black belt in karate and kung fu, is practicing for an upcoming belt promotion test. During practice, she wants to run through the 2 of the 5 weapon forms she knows. So she knows 5, she's just going to do 2 at a time during her practice. In how many different orders could Lila practice these forms? So it's 5 things taken 2 at a time. So it's going to be 5 factorial over 5 minus 2 factorial. And again, you can do that by hand pretty easily. Or on your calculator, I can go over to Math, go over to my PRB menu. On the CE, it says PROB, but on the TI-84 Plus, it just says PRB. And then you can choose number 2. And I can type in 5 things taken 2 at a time, and it'll figure it out for me. If you're lucky enough to have the CE, you can go to Alpha Window, and it's number 7. So there are 20 different ways that Lila can practice those 2 out of 5 forms. For combinations, what if the order doesn't matter? That's called a combination. An example would be choosing 5 bridesmaids out of your 10 best friends, choosing a committee of 4 out of the 30 people that are attending the meeting, choosing 2 puppies from a litter of 8. It doesn't matter what order that we select those things in, it's just how many different groups can we create of those numbers. And this is the formula. Basically, you have to divide off all of the duplicates that you're going to get when you do the permutation. It's n factorial over r factorial times the quantity n minus r factorial. It's the same thing as the permutation formula, we're just adding an r factorial in the bottom. There are 12 employees at the sub shop. How many ways can the manager choose 4 for the Sunday evening shift? So it doesn't matter whether he chooses them in order of Joey, Samantha, Carrie, and Erica, or if there's a different order to those 4, that's going to count as one arrangement. So just like our order up here, where we were just selecting 2 people out of the committee, and AB is the same thing as BA. We're going to do a permutation, but then we're going to divide off to cancel all of the duplicates where we have AB being the same as the BA. It's 12 employees, so same thing. We're taking 12 people, 4 at a time. So you just plug in those numbers, 12 factorial over 4 factorial times 12 minus 4 factorial. Again, this is the only part that we're adding that's different for this formula, and that's going to divide off all the duplicates. So we're going to have 12 factorial over 4 factorial times 8 factorial. Okay? Now that doesn't mean 32 factorial. You actually have to like multiply all of the things together. I really quickly put that in my calculator. To get the fraction, again, that's alpha y equals on any calculator. You can choose number 1. And then just a reminder to get the exclamation point, that's math over to PRB or PROB and choose number 4, or alpha window on the TI-84 Plus CE. You can see the exclamation point there. And the answer was 495 ways that this manager can select 4 people out of 12 employees for the Sunday evening shift. That's a lot of ways. All right, really quickly, one of the things that's challenging is deciding whether it's a permutation or a combination. So here are some examples that are permutation, and here are some examples that are combination. Hopefully that gives you a pretty good overview of permutations and combinations.